Or you've made an unusual choice for bedtime listening. Most people wind down with ocean waves, maybe a forest breeze, or the sound of a cat purring. And here you are, tucking yourself in with the thought of a planet that could vaporize your body faster than a marshmallow dropped into a campfire. But that's the charm of Venus. It's close, familiar, a neighbor in our solar system, and yet utterly, unrelentingly hostile. No beaches, no cozy clouds, no, let's take a picnic. Just a slow cooker of carbon dioxide, sulfur, and pressure that would flatten you flatter than a pressed flower between encyclopedias. So tonight, instead of drifting off imagining soft grasses or candlelight, you'll drift off imagining the world where candles would melt before you lit them, where the air itself wants to crush and dissolve you, where the forecast is 860 degrees Fahrenheit, 900 if you're standing in a particularly sunny spot. And strangely, that's soothing. Because compared to Venus, whatever happened in your day probably wasn't so bad. So let's take a nice deep breath of our Earth air, marvelous, breathable, unburning Earth air, and sink slowly into this story. Welcome to Why You Wouldn't Last an Hour on Venus and More. If, for some unfathomable reason, you decided to step out onto the surface of Venus, the first thing you would notice, if you had the luxury of noticing anything before disintegrating, is the sheer wrongness of it all. Venus looks a little like Earth from space, roughly the same size, about the same density, cloaked in clouds that, at first glance, might remind you of our weather. But down here, at ground level, it's the sort of family resemblance that makes you realize the family reunion has gone terribly off the rails. The ground itself is a cracked, sunburnt wasteland of basaltic rock, shaped long ago by volcanoes that once belched rivers of molten material across the land. The surface doesn't glow with active lava now, but it carries the memory of fire. It looks baked, desiccated, as though it has been roasted slowly in an oven for a few billion years. And in fact, that's exactly what has happened. The rocks here are not cool companions, as they might be on an earthly hike, but reluctant survivors of a planetary bake-off. The light filtering through the sky adds to the strangeness. The sun is up there somewhere, but you wouldn't see it clearly. Instead, it arrives as a pale, weak disk struggling through a soup of cloud. The glow is yellowish, mustard-tinted, with a heaviness that makes everything feel suffocatingly dim. Imagine walking outside at noon on Earth, but through a fogged glass window that never clears. The shadows are strange, hazy and close. The sky presses down, rather than opening up. And the heat. Let's not forget the heat, because Venus certainly won't let you forget it. It surrounds you like a suffocating blanket, a constant assault from every direction. 860 degrees Fahrenheit on average. Hotter still in certain regions. Enough to melt lead, enough to warp metal, enough to make you nostalgic for lava. This isn't a dry desert heat, the kind you complain about on holiday before returning to your air-conditioned hotel. This is heat, as an existential fact. Heat so deep and unyielding that even imagining shade feels laughable. Shade from what? The air itself radiates warmth. The ground radiates warmth. There is no escape, no breeze, no reprieve. Just the steady, unending insistence of an atmosphere that has been simmering for longer than life has existed on Earth. If you came here in a top-of-the-line spacesuit, the kind carefully engineered for human survival in extreme environments, you might feel an initial sense of security, but it would be a false comfort, because the suit would already be protesting. Its cooling systems would strain, its electronics would heat up, and its carefully designed layers would begin to warp ever so slightly. Nothing man-made has been built for this environment to last long. Standing here is not a matter of how will you manage the day, but how many minutes before this turns catastrophic. So yes, first impressions of Venus: rocky, dim, unbearably hot, and immediately fatal. The sort of vacation destination you'd rate with 1 star on a travel app. Mostly because 0 stars wasn't an option. Of course, the landscape itself isn't the only problem. You might think, optimistically, that the ground is survivable with the right protection, but the true menace of Venus is in the air. Except it's not really air, is it? Not in any way we would use the word. Air, to us, implies something you can breathe. Something that nourishes your lungs. Something friendly. Venus has none of that. The atmosphere here is more like a suffocating stew. It is thick, over 90 times denser than Earth's atmosphere at sea level. Breathing in, without a suit, would not simply hurt you, it would be impossible. The air is composed almost entirely of carbon dioxide, and your lungs, so accustomed to the luxury of oxygen, would collapse into panic within seconds. Even if there were a trace of oxygen, the pressure would flatten your chest long before you could inhale. It's less like choking, and more like having your entire respiratory system politely denied entry. And then there is the acid. High above, thick clouds swirl, and they are laced with droplets of sulfuric acid. If that sounds like a villain's weapon from a comic book, that's because it basically is. Here, though, it isn't dramatized. It's the baseline. On Earth, clouds can bring gentle rain, soft mist, refreshing drizzle. On Venus, the clouds bring an ever-present reminder that even the sky is corrosive. If a droplet touched your skin, it wouldn't sting, it would dissolve. Slowly, steadily, irrevocably. The air presses in from every direction. On Earth, our atmosphere exerts around 14 pounds of pressure per square inch. Manageable. We barely notice it. On Venus, the pressure climbs to about 350 pounds per square inch. That's roughly the same as the force you'd experience a kilometer under the ocean. The weight is so immense that, without the shelter of an impossibly strong suit, you wouldn't be able to stand. Not because your muscles gave out, but because your skeleton itself would fail. You would simply be compacted. The atmosphere itself, invisible and unavoidable, would become a crushing, suffocating fist. And this isn't even weather. This is the default. Venus doesn't offer sunny days and cloudy days, pleasant breezes and occasional storms. It simply exists as one long, never-ending assault of pressure, suffocation, and corrosion. The forecast is the same every day, unbearable. If air is supposed to be a gentle companion, Venus's version is more like being locked in a sauna designed by someone who hated you personally. Now, let's imagine, indulgently, that you have a state-of-the-art Venus suit. Reinforced, pressurized, cooled. A marvel of engineering. You step out onto the surface and begin your brief, impossible stroll. What does your last hour look like? Minute 1. The suit does its best. You are walking in slow motion, weighed down not only by the gravity, similar to Earth's, so deceptively familiar, but by the density of the atmosphere pressing against every movement. Each step feels like wading through invisible molasses. The heat presses in immediately. You feel nothing directly, but your suit registers everything, and its cooling systems whir at full power to compensate. Minute 5. The systems strain. Tiny alarms begin to chirp in your helmet, politely at first, then more insistently. Temperatures inside the suit creep upward. The external layers, though carefully designed, begin to expand and warp. Metals soften at these extremes. Plastics grow weary. The sulfuric haze above you eats away, molecule by molecule, at seals and joints. Minute 10. Condensation forms on your visor, not from the planet, but from your own sweat and the struggling temperature regulators. It blurs your view of the dim, oppressive landscape. You see vague shapes of ridges and rocks through a fog of your own making. Breathing becomes harder. Not because the air is gone, but because the cooling oxygen reserves are dwindling faster than anticipated. Minute 15. The internal temperature climbs. The suit is effectively cooking you now, trapping your body heat inside, while simultaneously struggling against the inferno outside. Your limbs grow heavy, your muscles sluggish. You feel as though you are swimming in boiling water, except there is no water, just the relentless squeeze of the atmosphere and the heavy, hot air you cannot touch. By minute 30, if you are absurdly lucky, the systems begin to fail altogether. A crack in a seal, a buckle in the visor. The crushing weight of Venus seizes the opportunity. The suit collapses inward with terrifying inevitability. You are compressed, overheated, suffocated, and dissolved all at once. And, if by some cosmic indulgence you lasted the full hour, you would not be standing at the end of it. You would be a crumpled artifact, a reminder to future explorers that Venus is not a planet to be visited casually. It is not a place that tolerates life. It is a furnace, a pressure chamber, and a vat of acid, wrapped into one deceptively Earth-sized package. Venus does not hate you personally. Venus hates everyone equally. On Earth, air is the invisible friend we rarely think about. It slips in and out of your lungs all day, doing the unglamorous but vital work of keeping you alive. You don't notice it, you don't thank it, but on Venus, you would notice the air immediately, not because it helps you, but because it's the reason you wouldn't last. Here the atmosphere is thick, so thick that describing it as air feels almost dishonest. It is more like being surrounded by an invisible ocean. Imagine swimming underwater, but without the coolness, without the buoyancy, without the pleasant hush of waves. Replace that with suffocation, heat and pressure, and you're closer to the Venusian experience. The composition is unkind to life as we know it, 96% carbon dioxide. That's not just too much carbon dioxide, it's the entire room. If you tried to take a breath here, there would be no oxygen to collect. Your lungs would fill with a gas that does nothing for your body. It's the biological equivalent of eating a meal of styrofoam. You can go through the motions, but nothing nourishing happens. On Earth, small amounts of carbon dioxide trigger a sense of urgency, a warning bell in your nervous system. Breathe faster, take in more air. On Venus, your body would ring that alarm endlessly, searching for oxygen that does not exist. A panic without resolution. The cruel trick of breathing harder into lungs that will never receive what they need. Even if you somehow ignored the suffocation, you couldn't escape the sheer density. This isn't a wispy, invisible film like Earth's sky. It's a wall. A crushing invisible syrup pressing in on every direction. And it is hot. You don't just suffocate here. You boil. High above, where Earth has clouds of water vapor, Venus carries its own exotic weather. But instead of refreshing rain, the Venusian sky offers sulfuric acid. The kind of chemical we treat very carefully in laboratories back home, stored in thick bottles with hazard symbols plastered on the side. Here, it is not in bottles. It is the weather. Sulfuric acid droplets float in the upper atmosphere, suspended like mist. If you could drift high into the clouds, the scenery might even look almost familiar. Wispy layers, rolling forms, light breaking through in faint glows. But what you're looking at is a haze of corrosive liquid. It's rain with teeth. If a single droplet landed on your skin, it wouldn't feel like water. It would burn, not with a dramatic sizzle, but with a steady dissolving patience. It would eat at the proteins of your skin, breaking down the very structures that hold you together, not quickly, not theatrically, but methodically. On Earth, we associate acid with bubbling science experiments. On Venus, it's just part of the forecast. The sulfur gives the air a pungent quality too. Imagine the stench of rotten eggs, multiplied, heated, thickened. That smell is carried everywhere here. Not that you'd be around long enough to complain about the odor. Your nose, like the rest of you, would already be failing under the weight of pressure and heat. These clouds don't bring showers in the way we think of them on Earth. Raindrops begin to form, yes. But before they can fall to the ground, the oppressive heat of the lower atmosphere vaporizes them away. It's a cycle of false promises. The clouds form droplets, gravity pulls them down, and then the fire below says no. The result is a sky filled with endless acid that never quite completes its fall. So the air of Venus isn't just unbreathable. It's actively hostile, seething with corrosive mist. The sky itself, the very thing we often look up to for comfort, is a hazard. On Earth, clouds can signal storms or shade or change. On Venus, they simply signal danger. Now let's sink lower, down into the weight of it all. The pressure of Venus is relentless, the kind of crushing force that cannot be reasoned with. On Earth, we live beneath a comforting blanket of atmosphere, just heavy enough to hold us steady, just gentle enough that we never notice. At sea level, that weight is about 14 pounds per square inch. It sounds like a lot, but our bodies evolved under it. We wear it like a second skin. On Venus, the same measurement becomes monstrous, more than 90 times heavier, over 300 pounds pressing against each square inch of your body. Imagine holding a car on every shoulder, on every arm, on every fingertip, and not just one car. The entire weight distributed across every fraction of your skin. It isn't something you could train for, or resist, or strengthen yourself against. It's simply too much. This kind of force doesn't just press, it changes the rules. Gases behave differently. Rocks deform differently. Metal softens under the combined punishment of heat and pressure. If you were standing here, your bones wouldn't crack dramatically like in a film. Instead, you would simply compress. Your lungs wouldn't just fail to inflate, they would collapse like deflated balloons. Your body, so carefully structured for Earth, would become something else entirely under the weight. And yet, despite this crushing atmosphere, Venus is not a quiet place. Winds whip through the upper layers at speeds faster than hurricanes on Earth, racing around the planet in just a few days. Near the ground, those winds slow, choked by density. Here, the air doesn't move quickly. It moves with weight, with the ponderous push of syrupy fluid. Every gust is heavy. Every breeze is an avalanche you cannot see. It is strange to think of air, normally the gentlest thing we know, as a lethal physical weight. On Earth, air is something we barely notice. On Venus, it is the most immediate reminder that you do not belong here. And that is the essence of this world's atmosphere. It is not simply unbreathable, or corrosive or heavy. It is all of those things at once. A suffocating stew, a choking haze, a pressure cooker without escape. Venus does not invite life. It ensures that life cannot enter. Picture it. You've just landed. Against your better judgment, the hatch opens, and you step down onto Venus. If this were a film, this would be the heroic moment. The astronaut planting a flag, posing for history. But in this scenario, the first thing you notice isn't pride. It's the fact that breathing is not happening, not in the usual sense. You instinctively try to inhale, but there is nothing useful in the air. It's like trying to fill your lungs with stone. No oxygen, just carbon dioxide, and lots of it. Your chest feels tight immediately, not after a few minutes, but right away, as though someone is pressing down with their hand. Your brain, trained by Earth's air, rings alarm bells instantly. You need oxygen, more of it now. But the cruel joke of Venus is that there isn't any. No matter how fast you breathe, no matter how deeply, the oxygen never arrives. You can imagine your body's confusion. The sensors in your blood scream for relief. Your diaphragm heaves, your heart speeds up. But every breath is a wasted effort. It's like trying to quench your thirst with sand. And all the while the air is pressing on you from every direction. Not lightly, not gently, but like the bottom of an ocean that forgot to end. Even if, in this little thought experiment, you have a spacesuit, the sensation isn't much kinder. The air outside pounds against the suit relentlessly. You can feel its weight through the vibrations, the groaning of materials that were never truly designed for this place. Each breath you take inside your helmet feels thin, filtered, precious, because it is. You are carrying a tiny bubble of Earth in a place that does not want it. The first few minutes are a tug-of-war between instinct and environment, a futile argument where your lungs lose every round. Soon, the heat asserts itself. Not as a wave, not as a sudden flare, but as a constant, omnipresent blanket. You've been in hot places before, summer afternoons, saunas, maybe even deserts. But those environments always offered hope. A breeze, a patch of shade, the coolness of night eventually arriving. Venus offers none of that. Here, the heat is simply permanent. Imagine standing inside a pizza oven, set not to bake, but to melt. The rocks beneath your feet glow faintly, not with light, but with the retained energy of endless sunlight, trapped and re-radiated by the thick atmosphere. The air itself seems to press warmth into your skin, into your bones, into every molecule of your body. Even in a protective suit, the illusion of safety quickly crumbles. Cooling systems hum desperately, fighting against the impossible. At first, you feel only a creeping warmth, then it becomes sweat, then it becomes stifling. Your visor begins to fog, not because of the planet's haze, but because of condensation inside, your own body struggling against its furnace of a container. If you could stand still long enough to notice your surroundings, you'd see a landscape shaped by this heat, rock plains, volcanic remnants, ridges etched into the surface like scars. The ground is cracked, baked, unforgiving. No rivers, no lakes, no snowcaps, just rock, rock and more rock, all cooked under the same relentless sun. And it does not cool. On Earth, even deserts lose their heat when the sun dips. On Venus, the thick blanket of carbon dioxide traps the warmth with no escape. Nighttime doesn't exist here in the way we know it. There is only day, stretched into eternity, with no relief waiting on the horizon. So the heat presses in, constant and unyielding, not a wave, not a storm, but a fact. You are not visiting Venus, you are being baked by it. Let's indulge the scenario further, and imagine you are still standing. Minutes pass, your suit holds for a little while bravely. The alarms beep, the readouts flicker, but you remain upright, fighting to keep moving through the soup of pressure. The pressure continues to squeeze. It isn't dramatic. It doesn't crush you in an instant. It is worse than that. It is slow, steady, inevitable. A tire that slowly deflates. A can that buckles under weight. A body that is no longer built for its own shape. Every joint in the suit groans. Every seal grows weaker. You hear faint creaks, the sound of engineering pushed beyond its limits. The air outside weighs heavily, so heavily that your very presence feels absurd. You are an intruder here, a fragile thing pretending to belong in an environment designed to erase fragility. Each step is an argument against physics, and physics always wins in the end. By the half-hour mark, the heat inside your suit rises dangerously. The systems sputter, your movements slow, your limbs feel like lead, not from exhaustion, but from the combined drag of heat and pressure. And then the collapse begins. A crack in a seal, a buckle in the visor, a weakness somewhere in the protective shell. The pressure pounces on the opportunity. It does not wait. The atmosphere surges inward, crushing, suffocating, overwhelming. If you had managed to survive longer than most, congratulations, but the end is the same. Venus does not make exceptions. It does not negotiate. Within an hour, likely far less, you are gone. A brief experiment in defiance undone by a planet that was never interested in compromise. Venus doesn't just resist life. It erases the very idea of it. Carl Sagan was born in Brooklyn in 1934, in a world that had never yet sent anything into space. Not even a satellite, not a probe, certainly not a human being. The night sky at that time was still firmly in the category of something you admire out the window while brushing your teeth, and yet, young Carl treated it as though it were the most pressing reality in his life. Imagine being a boy in Depression-era Brooklyn, and, instead of worrying about stickball or penny candy, you're staring upward at the pinpricks of light, wondering what they are. Not simply dots, not ornaments, but worlds, planets, suns, possibilities. Other people might have looked up and thought, nice stars. Carl looked up and thought, what is the chemical composition of those stars? And might anyone be home around them? Which, for a child, is a suspiciously large question to ask. He had parents who nurtured this curiosity in their own ways. His mother, Rachel, was the ambitious one, the dreamer who encouraged him to chase opportunities beyond their modest means. His father, Sam, was steady, practical, a garment worker who supplied the kind of quiet support that made Carl's wild imagination possible. In this unlikely combination of practicality and ambition, Carl found the balance he needed to launch into the stars, figuratively at least. And it wasn't just the stars. He was a voracious reader, devouring science books from the library, clunky volumes with faded bindings and titles like Wonders of the Universe, that probably smelled faintly of dust and glue. He was exactly the sort of child who would ask his teachers difficult questions, not out of defiance, but out of sheer enthusiasm. The sort of boy who might corner you at a birthday party to explain the life cycle of a star, and you'd nod politely while wondering if there was still cake left. Brooklyn didn't exactly offer starry skies free of light pollution, even then. But Sagan didn't need perfect conditions to cultivate wonder. All he needed was the faint idea that those distant pinpricks were not just background decoration, they were places, and once that idea lodged in his mind, it never left. This is the kind of childhood detail that seems obvious in hindsight. Of course, Carl Sagan was always going to become Carl Sagan. The boy staring at the sky becomes the man who convinces the rest of us to stare too. But at the time he was just a curious kid with a telescope, poking at the universe with a mixture of seriousness and childlike awe. The rest of the world was playing baseball. Carl was waiting for the future. Curiosity in Carl was not a passing phase. For many children, science is a brief flirtation, a butterfly collection, a soda bottle volcano before they wander off to other hobbies. Carl, however, treated curiosity like a full-time job. He wanted to know how everything worked, and then he wanted to know why it worked that way, and then, once he understood that, he wanted to explain it to you, whether you asked for an explanation or not. He built model rockets, tinkered with chemistry sets, and read every scrap of astronomy he could find. Remember, this was before the space age, before Sputnik, before NASA was even founded. Space travel existed in pulp magazines and science fiction novels, not in reality. To many, dreaming about going to the stars was no more practical than dreaming about being a knight or a cowboy. But Carl didn't see it that way. To him, the possibility wasn't absurd, it was inevitable. The real question was when and how and what would we find when we got there. It takes a certain kind of temperament to be this obsessed without being discouraged. He didn't have access to fancy equipment. He didn't have wealthy patrons or immediate opportunities. What he had was a mind that refused to let go of the idea that the universe was knowable, and that knowing it mattered. There's a certain dry humor in imagining young Carl pestering his teachers. "Excuse me, but have you considered the greenhouse effect on Venus?" he might ask, decades before most people knew Venus had one. You can imagine the teacher blinking at him, chalk in hand, silently weighing whether to answer honestly or just suggest recess. It's the kind of relentless curiosity that is exhausting for adults around a child, but occasionally, just occasionally, it turns out to be exactly the right kind of obsession to change the world. He wasn't all seriousness, though. Friends remembered him as warm, funny, easy to talk to, the kind of person who could turn even the driest scientific point into a story. This trait would become his trademark later, the ability to make the cosmos feel personal, conversational, something you wanted to sit around and chat about. But even in his youth, that knack was there, the balance of scientific rigor and approachable charm. So while other children were memorizing baseball stats, Carl was memorizing star charts. While others were thinking about the next school dance, Carl was thinking about the next galaxy, which, in retrospect, is exactly what you want from a man who would later try to explain the universe to the rest of us at bedtime. By the time he was a teenager, Sagan had already become something more than just interested in science. He had crossed into philosophy, not the kind with togas and scrolls, but the kind that asks, what does it mean to be alive in a universe this large? He wondered about extraterrestrial life, not as fantasy, but as probability. Statistically speaking, he reasoned, the cosmos is simply too vast for us to be alone. This wasn't the daydreaming of a sci-fi fan, though he certainly enjoyed science fiction. It was the careful thinking of someone who recognized scale, who understood that the billions of stars above Brooklyn each carried their own possibilities. For Carl, science was never just a collection of facts, it was a story. The story of how hydrogen atoms became suns, how suns cooked heavier elements, how those elements formed planets, and how, on at least one of those planets, life emerged. To him, we were not separate from the stars but continuous with them, made of the same materials, unfolding from the same physics. It's a thought that might keep some people awake at night, but for Carl it was comfort, a grand cosmic belonging. It's funny to think of a teenager wandering the streets of New York, carrying such immense thoughts in his head. Other kids may have been worrying about homework or part-time jobs, but Carl was mentally cataloguing galaxies. He was, in a sense, already practicing for his later career, helping the rest of us feel both small and significant at the same time. There's an irony here, of course. While the young Sagan was thinking about the vastness of space, the actual human world was teetering on the brink of world war, rationing and upheaval. The local problems of Earth were pressing, urgent, immediate. Yet Carl's mind stretched past them, out to a scale where human conflict seemed tiny compared to the unfolding grandeur of the cosmos. That contrast between the urgent squabbles of Earth and the calm immensity of space would shape the way he later explained science to the public. So, in these early years, we see the outline of the man he would become, the boy who never stopped looking up, who never stopped asking why, and who never lost the conviction that the answers, when they came, would matter to everyone. By the early 1960s, the world had changed in a way that seemed almost tailor-made for Carl Sagan. Humanity had finally invented a way to turn science fiction into real hardware, rockets. Suddenly, all the daydreams that once belonged solely to pulp magazines and late-night telescope gazing were being welded together in metal, rivets, and liquid fuel. And Sagan, with impeccable timing, arrived in the middle of it all. Fresh out of the University of Chicago with his PhD in astronomy and astrophysics, he stepped into NASA's orbit at exactly the moment the agency was trying to figure out what was actually out there. The Moon was on the horizon, Mars and Venus were targets, and Jupiter loomed in the distance like a giant waiting to be noticed. Humanity was about to start looking closely at these places for the very first time. And Sagan, with his relentless curiosity and his unnerving habit of asking very big questions in very small rooms, was suddenly indispensable. He wasn't the one building the rockets or soldering the electronics. That wasn't his strength. His talent was in interpretation. He could look at a grainy radio signal, or a blurred photograph, and spin it into a story about an entire world. While engineers worried about trajectory corrections, Carl was wondering what kind of clouds were on Venus, or what the winds were like on Mars. He was in essence the translator between raw data and cosmic meaning. NASA, of course, loved people like that, though perhaps a little reluctantly at times. Engineers tend to be practical, focused on what the instruments can actually measure. Sagan had the annoying habit of saying yes but what else might be true, which was occasionally maddening but more often exactly the spark they needed. The timing was perfect. The Mariner probes were being launched toward Venus and Mars, Pioneer was headed toward Jupiter, and a young Carl Sagan was right there, whispering interpretations of alien weather reports before anyone else had the vocabulary. He was, in short, at the right place at the right time, with the right imagination. If Sagan had a signature discovery, it was his work on Venus. At the time, many scientists still had a surprisingly optimistic view of the planet. From Earth, Venus looks cloudy, mysterious, perpetually wrapped in a bright shroud. Some people wondered if those clouds might conceal oceans, or jungles, or at least something survivable. The idea of Venus as a swampy twin of Earth was strangely popular. Science fiction had already run with it. Carl Sagan politely, and with the calm brutality of data, ruined that dream. He was one of the first to show convincingly that Venus wasn't a steamy jungle at all. It was a pressure cooker. He studied how sunlight, trapped by the dense carbon dioxide atmosphere, created a runaway greenhouse effect. On Earth, greenhouse gases make life possible by keeping us warm enough. On Venus, the same principle was turned up to 11. The result, a planet hot enough to melt lead. This wasn't just a neat planetary fact, it was a revelation. It reshaped how we thought about atmospheres, about climate, and eventually, uncomfortably, about ourselves. Because if a runaway greenhouse effect could happen there, what might happen here if we weren't careful? Venus became not just a cautionary tale about planetary climate, but also a quiet warning about our own. Sagan had a way of explaining this that was both scientifically rigorous and dryly witty. You can almost hear him saying, if you're looking for a vacation destination, don't pick Venus. Unless, of course, you're very fond of being crushed, baked and dissolved. His sense of humor softened the bleakness, but the message was clear. Venus wasn't just hostile. It was a reminder that planets are fragile, and atmospheres can turn against you if given the chance. At NASA, this made him both popular and occasionally irritating. Engineers liked numbers, administrators liked optimism. And here was Carl, gently pointing out that one of our nearest neighbors was less a tropical paradise, and more a death oven. But he was right, and the data confirmed it again and again. Venus was not just unfriendly, it was utterly hostile, and Carl was the one who said so, loudly, clearly, and with the calm authority of someone who'd done the math. Sagan's role at NASA wasn't confined to Venus, though. He had a hand in shaping the interpretation of Mars, of Jupiter, and later, even in thinking about the outer planets. He advised on missions like Mariner, Pioneer, and eventually Voyager, each time helping craft the questions we ought to be asking. Where others saw a blurry black and white image of a cratered surface, Sagan saw stories, climate histories, geologic upheavals, the fingerprints of processes that had been playing out for billions of years. And then, famously, there was his involvement in the search for life. Not the overexcited little green men sort of life, but the sober scientific version. If life could exist anywhere beyond Earth, how might we recognize it? He helped design messages to be sent on spacecraft. Records, plaques, encoded greetings, tiny golden invitations flung into the dark, in case anyone, anywhere, ever found them. He was, in other words, one of the first to seriously argue that humanity should introduce itself to the cosmos, politely and optimistically, like a neighbor leaning over the fence. This was classic Carl. Practical but expansive. Serious but tinged with wonder. He wasn't content to just measure planetary temperatures or plot orbital mechanics. He wanted to fold those details back into the larger human story. What do these discoveries mean for us, for our future, for our place in the universe? Working at NASA gave him the perfect stage. He stood at the crossroads of engineering, astronomy, and philosophy, and somehow managed to speak all three languages. To the engineers, he talked about data. To the public, he told stories. To himself, he kept asking questions that were too large to fit neatly in a lab report. By the end of the 1960s, Carl Sagan wasn't just a promising scientist. He was a voice that translated the cold precision of planetary science into something warm, human, and oddly comforting. He was becoming the Carl Sagan we recognize today. The one who could stand beside a probe designed to survive the harshness of Venus, and, instead of talking about circuits and insulation, quietly remind us that we are all made of star stuff. By the 1970s, Carl Sagan had already made his mark inside scientific circles. His papers on planetary atmospheres, his work on climate models, his fingerprints on the Mariner and Viking missions, all of it had established him as one of the key minds of the space age. But Sagan was restless. It wasn't enough for him to share discoveries in journals read by a few thousand colleagues. He wanted everyone. Taxi drivers, school kids, night shift workers, retired grandmothers, to understand that they lived on a tiny speck of dust in a vast cosmic sea. The trouble was, academia didn't exactly encourage this sort of thing. Most professors, when given a choice, preferred publishing one more technical paper over appearing on television. Public outreach was considered almost frivolous, something done on the side, like knitting or playing bridge. But Carl treated it as central. For him, what good was all this discovery if it remained locked in the heads of specialists? So he became something rare, a professor who chased primetime slots. He appeared on The Tonight Show with Johnny Carson, patiently explaining black holes and planetary atmospheres to audiences who normally tuned in for celebrity banter and musical numbers. He was witty, calm, a little mischievous. He could sit there in his trademark turtleneck and casually drop the phrase billions and billions, with a twinkle in his eye, turning what might sound intimidating into something oddly friendly. And here's the thing, people loved it. While most scientists were happy being anonymous background figures, Carl became a household name. Your uncle might not remember his own blood pressure, but he knew Carl Sagan was the man who thought the stars were important. Scientists were slightly jealous, some were mildly irritated, but the public adored him. He had cracked a code. Science, delivered with poetry and patience, could be entertaining. It was, in a way, his rebellion against the dusty stereotype of science. Instead of muttering equations on a chalkboard, he told stories. He reminded us that astronomy wasn't just about numbers, it was about perspective. He had the nerve to say that learning about galaxies was just as relevant to daily life as knowing how to make dinner. Which is bold, because galaxies don't actually keep you fed. But Sagan's point was simple: they feed your sense of meaning. Everything came together in 1980 with Cosmos, A Personal Voyage, a 13-part television series that did for astronomy what Attenborough documentaries did for wildlife. It was part science lecture, part history, part love letter to the universe, and it was all delivered in Sagan's unmistakable voice, calm and reverent, with just enough sly humor to keep you awake. The production spared no effort. Sweeping visuals of galaxies, historical reenactments of ancient astronomers scribbling under candlelight, Sagan strolling dramatically through what looked like an interstellar set, waving his arms gently as though conducting an orchestra of stars. It was theatrical, yes, but it worked. Cosmos became the most watched science show of its time, seen by 500 million people worldwide. For many viewers, this was their first real encounter with the scale of the universe. Sagan could pivot from describing a nebula to pointing out that every single human drama, wars, romances, grocery lists, had all unfolded on a mote of dust suspended in a sunbeam. And audiences didn't find that depressing, they found it liberating. Somehow he convinced people that their smallness in the universe was not a tragedy, but a source of wonder. And of course there was his dry wit. When describing extraterrestrial civilizations, he'd raise an eyebrow and say, "Extraordinary claims require extraordinary evidence," a line so crisp it became a catchphrase. When talking about the possibility of alien contact, he didn't promise little green men. He offered probability, perspective, and a gentle shrug. "If we're alone," he'd say, "it seems like an awful waste of space." He had a gift for making vast ideas sound like casual observations you might share over coffee. Behind the calm delivery, though, there was urgency. Cosmos wasn't just about stars and galaxies, it was also about Earth, climate change, nuclear war, environmental collapse. Sagan used his cosmic pulpit to remind people that while the universe was vast, our home was fragile. Compared to Venus, Earth was a paradise, but like Venus, it could tip into disaster if we weren't careful. Viewers tuned in expecting space opera. They came away with a plea for planetary responsibility. And somehow, they liked it. If Cosmos made him famous, it was the Voyager spacecraft that gave Carl Sagan his most enduring metaphor. In 1990, as Voyager 1 was about to leave the solar system, Sagan suggested turning the camera back toward Earth. The result was a tiny, almost laughably insignificant image. Earth reduced to a single pale dot, suspended in the darkness, barely even visible against the glare of scattered sunlight. Most scientists might have filed it away as a neat curiosity. Sagan turned it into philosophy. His reflection on the image is now legendary. That dot, he reminded us, was everyone. Every king and queen, every hunter and farmer, every teacher and child, every argument, every story, all of it had taken place on that pixel. It was his ultimate lesson in humility. You don't need gods or myths to feel small. The cosmos itself is more than enough. But in Sagan's telling, smallness wasn't despair, it was perspective. If we are fragile and fleeting, then all the more reason to be kind to each other, to care for our little world, and to keep looking outward. By the end of his life, Carl Sagan had become more than a scientist. He was a cultural figure, a kind of secular preacher for the universe, who could move seamlessly from calculating planetary temperatures to writing sentences that made people cry. He was playful, sharp, sometimes controversial, occasionally mocked, but always unforgettable. And in the end, his message was simple: We are star stuff, contemplating the stars. Not special in the cosmic sense, but special because we have the ability to recognize the vastness around us. He reminded us that looking outward was also a way of looking inward. So if you find yourself drifting to sleep tonight, comfort yourself with this. Carl Sagan spent his life telling us that the universe is huge, terrifying and unknowable, and that this is somehow wonderful news. When you look at Venus from afar, through a telescope or one of those crisp NASA images, it seems almost polite, a smooth, cream-colored orb, with a soft, hazy blanket of cloud that hides everything underneath. At first glance you might think it's tranquil, like a giant pearl quietly hanging in the solar system. No scars, no violent storms like Jupiter, no rings like Saturn, no screaming red dust storms like Mars, just a calm, opaque world. But this, as usual, is a trap. Because the truth is, while Venus might look serene, its atmosphere is doing something absurd. The entire upper cloud deck, thick layers of carbon dioxide gas laced with sulfuric acid, doesn't just sit still. It races around the planet at hurricane speeds, circling the globe in about 4 Earth days. Which wouldn't be so strange, except for one glaring detail. Venus itself takes 243 Earth days to rotate once. In other words, the ground beneath is barely turning, while the sky above is lapping it again and again, like an over-caffeinated runner around a very sluggish track. This is what scientists call superrotation. The atmosphere is moving 60 times faster than the planet itself. Imagine standing on a lazy merry-go-round, while the air around you is a full-speed roller coaster. That's Venus. It's the planetary equivalent of someone saying I'm not really into exercise, while secretly running ultramarathons. And of course no one knows exactly why. Theories abound. Maybe it's because of solar heating, the way the sun's energy strikes one side more intensely, and sets off giant waves of circulation. Maybe it's the planet's thick atmosphere itself, amplifying small motions until the whole thing whips around. Or maybe Venus just likes to be difficult. Whatever the case, the result is this bizarre spectacle. A world whose atmosphere is essentially in a permanent sprint, while the surface trudges along at a snail's pace. The effect is so extreme that if you dropped into the cloud tops with a balloon, you'd be carried around the entire planet in less than a week, whether you liked it or not. It's like the ultimate forced vacation cruise, except instead of Mai Tai sunsets, you'd get sulfuric acid mist and temperatures hot enough to melt lead. To appreciate just how fast these winds are, let's set the scene. On Earth we consider a 200-mile-per-hour hurricane catastrophic. Roofs fly off, trees uproot, entire coastlines change shape. On Venus, winds in the upper atmosphere can exceed those speeds all the time, without pause, without mercy, just endlessly howling across the cloud tops. And yet, strangely, if you somehow stood on the surface, ignoring of course the minor details of crushing pressure and fatal heat, you wouldn't actually feel much wind at all. Why? Because the atmosphere down below is so dense it acts like thick soup. The winds at the bottom move sluggishly, pushing against the extreme weight of air that sits above them. So near the ground it might feel like just a gentle breeze brushing against your suit, right before your suit collapses and you disintegrate. But let's set that aside. Higher up, where the atmosphere thins, the winds are free to scream. This means Venus offers a strange paradox. A world where the upper air is a permanent hurricane, while the surface is eerily still. It's like living in a house where the roof is being ripped off daily, but the living room is oddly calm. Except the living room is also 900 degrees and full of acid mist. Scientists have tried to model this for decades, and computers continue to sulk about it. The problem is scale. On Earth, wind patterns are influenced by oceans, continents, and seasonal changes. Venus has none of those things. No oceans to stir, no mountain ranges to redirect air. Just one big smooth frying pan of a planet. And yet its atmosphere insists on racing in circles. If you were a planetary scientist, this is the kind of thing that keeps you awake at night. Because it means we don't fully understand the rules of atmospheres. And if we don't understand Venus, a neighbor, a near twin to Earth, what hope do we have for figuring out the weather on exoplanets hundreds of light years away? Let's say, for the sake of sleepy imagination, that you could hitch a ride on a floating research balloon at the cloud tops of Venus. NASA has actually proposed this. It's one of the few places on Venus where a probe might last longer than a few hours, since the pressure and temperature up there are slightly less murderous. Not comfortable, mind you, but survivable for machines. So picture it. You're sitting in your gondola, drifting in the upper haze. Outside the porthole, the view isn't much to write home about. Endless yellowish clouds, thick as soup, stretching in every direction. You don't see a landscape, because the landscape is buried far beneath in a pressure cooker. You don't see stars, because the cloud deck is too thick. You are, essentially, inside a giant bowl of opaque broth. And yet, within that bland scenery, something remarkable is happening. Your balloon is being carried along at terrifying speed. Every hour, you're racing across thousands of kilometers, circling the planet without effort. You could set a world record for circumnavigation, except the only trophy you'd get is chemical burns from sulfuric acid drizzle. 4 days later, you've gone all the way round, not by choice, not with sails or engines, but because Venus has decided to carry you whether you like it or not. It's like the planet is reminding you that while it may look lazy from a distance, it can move with frightening efficiency when it feels like it. This is the essence of superrotation, a quiet planet with a sky that never stops running laps. It is baffling, elegant, and deeply inconvenient for anyone trying to design a probe that won't be shredded by corrosive wind-blown particles. And it stands as one of the solar system's most stubborn mysteries. Why does this happen, and why does it never stop? Scientists continue to puzzle over it, pouring equations into models, testing hypotheses, and mostly ending up with the answer, it's complicated. Which is a fine reminder that the universe isn't here to give us clean explanations. Sometimes, it's here to make us feel stupid. And Venus, it seems, takes that job very seriously. On Earth, when you say it's windy today, you're usually talking about a temporary condition. Maybe there's a front passing, or the jet stream dipped south, or your hat just doesn't stand a chance on the walk to the bus stop. Wind for us comes and goes. On Venus it doesn't come and go, it just is. Imagine a world where every day is hurricane season, but no one bothered to declare it. Up in the cloud tops, the winds don't take breaks, don't pause for calm mornings, don't give you one of those refreshing still evenings where the leaves don't move. No, Venus decided, let's make the whole atmosphere a permanent treadmill set to maximum. And it's not just one smooth stream either, it's layered, tangled and stubborn. Jet streams race in opposite directions, depending on altitude. Local eddies form and dissolve in minutes. Vast atmospheric waves, some the size of continents, ripple through the clouds, as if the planet is rolling over in its sleep and disturbing the covers. The winds themselves are not content to behave predictably. On Earth, weather forecasters get things wrong, but at least they have oceans and mountains to blame. Venus has none of those excuses, just a relatively smooth planet, and yet, the atmosphere insists on behaving like a restless toddler who refuses to sit still. This constant agitation has consequences. It redistributes heat, it churns sulfuric acid clouds, it grinds particles into fine hazes that further block sunlight. The result, a sky that isn't merely fast, but also chaotic. You wouldn't just be battered by a strong gust, you'd be endlessly swirled, tugged, and shoved in every possible direction, while trying to breathe an air supply made of carbon dioxide soup. In short, Venus doesn't just have wind, Venus is wind. One of the most puzzling features scientists discovered when they started peering at Venus in ultraviolet light was a gigantic wave stretching across its clouds. Not a little ripple, not a casual puff, a standing wave so enormous it literally spans most of the planet. It's like Venus has its own wrinkle, pressed into the atmosphere, that refuses to move. Earth does have atmospheric waves, jet stream undulations, gravity waves that ripple when air flows over mountains, that sort of thing. But Venus has no mountains high enough to explain a feature this huge. Instead, researchers suspect it might be caused by deep interactions between the sluggish lower atmosphere and the frantic upper winds, like two roommates who hate each other but can't move out. These waves make the atmosphere uneven. Instead of uniform winds, you get alternating regions of fast and slow rising and sinking. If you were drifting there in your hypothetical sulfuric acid-proof balloon, you'd notice the ride wasn't smooth. You'd climb, dip, sway, and occasionally wonder if the planet was trying to shake you off. And then there's the chemistry. These waves don't just move air, they shuffle around sulfur dioxide, water vapor, and other trace gases, creating bright and dark streaks when seen in ultraviolet. In other words, Venus's sky isn't just windy, it's streaky, patchy, marbled, almost like latte art, if your barista used poison and hostility instead of foam and love. This giant wave was so large and persistent that when the Japanese spacecraft Akatsuki spotted it, scientists were baffled all over again. Because here's the rule with Venus. Every time you think you've solved a mystery, the planet throws another one in your face, wrapped in acid clouds for good measure. Jet streams are supposed to be elegant. On Earth, they form neat bands, circling the planet, steering weather systems, allowing aeroplanes to hitch a ride for fuel efficiency. They're tidy, organized, almost gentlemanly. At least until they wobble and send you unexpected rain on your holiday. On Venus, the word organized doesn't apply. The jet streams in its atmosphere are fragmented, irregular, and temperamental. Some blow east, some west, some up, some down. Depending on altitude and latitude, you can find winds that seem to be part of entirely different weather systems, stacked on top of each other like a badly shuffled deck of cards. And the best part, they don't stay consistent. They shift, drift, and sometimes even reverse, as if the atmosphere itself is undecided about which way it wants to spin today. You could imagine some poor robotic weather probe, sending data back to Earth. Winds steady. Winds unsteady. Winds completely different now. Please advise. This patchwork of jet streams contributes to the broader superrotation, but also makes it almost impossible to model. The whole thing is like a planetary washing machine, stuck on spin cycle. Except instead of clothes, it's tossing around acid clouds and volcanic gases. If you were in that balloon we left behind in Chapter 7, by this point you'd be seasick, though technically airsick, rocked in every direction by winds that never agreed with each other. You wouldn't see a sunset, or stars, or ground, but you would get the singular joy of endless turbulence. Venus, it seems, wants its guests to be uncomfortable. And that is the reality of strange winds on Venus. Restless, layered, chaotic, and deeply confusing. They are the fine print beneath the bold headline of superrotation, and they remind us that even when we think we've captured the big picture, the details are messy. Venus doesn't just keep secrets, it keeps moving them around at 200 miles per hour. Science is supposed to be about clarity. You make observations, test hypotheses, build neat models, and then feel satisfied that you've wrestled chaos into order. Venus, however, is that one student in the class who refuses to follow the instructions and somehow still gets an A, while nobody else understands how. Take the superrotation of the atmosphere, for instance. We've described it, we've measured it, we've even watched it spin in real time. But the why of it, still unsettled. Is it the way solar heating drives waves? Is it tidal forces pulling and stretching the atmosphere? Is it something in the deep lower layers pushing upward? The truth is, we don't actually know. We have guesses, some very clever, but guesses nonetheless. Then there are the clouds. Their chemistry is unusual. The sulfuric acid part, sure, that's straightforward enough in the chemical horror show sense. But scientists keep finding hints of other compounds, like strange absorbers in the ultraviolet spectrum. Something up there is absorbing light in a way we don't fully understand. What is it? Dust? Exotic molecules? A trace of something life-related? No one can say for sure. Venus shrugs and says, "You'll never know," while hiding its cards under the table. And let's not forget the surface itself. Radar mapping shows volcanoes, mountains, vast lava plains. But are those volcanoes still active? Do they erupt occasionally, releasing plumes of gas? Or are they ancient relics of a violent past, now just geological ruins under a toxic sky? Evidence points both ways. Some scientists say yes, others say no, and Venus itself, true to form, has not provided a press release. In short, the mysteries aren't just minor details, they are central features. Venus is essentially an unsolved puzzle in planet form, one that we've been staring at for decades, and it only grows more frustrating the longer we look. This one deserves its own slow, deliberate section, because it's the unsolved question that draws the most attention. Could there be life floating in Venus's atmosphere? Now don't get carried away. We're not talking about intelligent beings building cloud cities or aliens waving politely from floating platforms. No. At best, we're talking about microbes. Tiny, hardy, unimaginably resilient microbes that might, just might, have found a way to eke out an existence in the cloud tops. Why there? Because at certain altitudes, the temperature is relatively Earth-like, around 30 degrees Celsius, 86 degrees Fahrenheit. It's not exactly pleasant, but compared to the surface sauna, it's paradise. And the pressure there is manageable too, about the same as standing on Earth's surface. So in that narrow atmospheric band, the Goldilocks zone of Venus, conditions are, let's say, less terrible. The problem is, the clouds are made of sulfuric acid. For life as we know it, that's about as welcoming as being asked to live permanently inside a bottle of bleach. Yet on Earth, we've found microbes that live in acidic hot springs, deep in mines, or floating in our own clouds. So the question remains tantalizing. Could Venus's atmosphere harbor some tiny acid-proof organisms? A few years ago, scientists detected phosphine gas, a chemical that, on Earth, is associated with biological processes. Cue headlines about possible life on Venus. But follow-up studies have been, let's say, less enthusiastic. Some confirm it, some doubt it, some say it might just be a measurement error. As of now, the verdict is, we don't know, and Venus isn't telling. So here we are, perched between life is everywhere, optimism, and Venus is just messing with us, skepticism. It's an unsolved question that keeps everyone awake. Ironically, perfect for a bedtime story. The most humbling thing about Venus is that we can't even list all the mysteries. It's not that we have answers waiting just around the corner, it's that we're not even sure what all the questions are yet. Why, for example, does the planet's surface seem to have been resurfaced in the relatively recent past, geologically speaking, maybe 500 million years ago? Did the whole crust overturn? Did massive lava flows wipe the slate clean? And if so, what triggered it? Why does the planet spin so slowly, once every 243 Earth days, and backwards, no less. Something must have happened to tilt and slow it, but what? Why is its magnetic field so faint compared to Earth's? Without a strong field, how does the atmosphere keep from leaking into space entirely? And perhaps the most profound mystery, why is Venus, Earth's twin in size and mass, so utterly different in character? Same starting conditions, wildly divergent outcomes. It's like looking at two siblings, one who became a kind, stable gardener, and one who became a heavy metal frontman who sets guitars on fire. The contrast itself is an unsolved question. Every spacecraft that visits Venus seems to come away with more data, but also more confusion. It's as if the planet enjoys trolling us, dangling hints of explanation but never quite delivering. For every aha moment there's an oh no that follows. And so Venus remains not just hostile but enigmatic. The kind of world that refuses to fit into neat equations, instead reminding us that the universe is under no obligation to make sense. Picture a room that hums gently, but not in any particularly romantic way. It's the hum of air conditioning, the buzz of fluorescent lights, the occasional whir of a printer that someone forgot to collect last week. Welcome to the Planetary Science Lab, less dramatic than a spaceship, but vastly more comfortable, with chairs that swivel, and a coffee machine that mostly works. The surfaces are cluttered with papers, sticky notes, and the odd rock sample sealed in a small glass case. Not Venus rocks, of course. Those are impossible to bring back. These are Earth rocks, basalt and volcanic specimens used as stand-ins. Planetary scientists spend a surprising amount of time staring at earthly rocks, pretending they're extraterrestrial ones. It's a little like studying domestic cats to understand lions. You don't get the full picture, but it's better than nothing. On one counter there's a stack of radar images from the Magellan mission, its microwave eyes having peered through Venus's clouds to reveal the contours of mountains and plains. The images aren't glossy or dramatic. They're grainy, grayscale maps, like photocopies of topographic dreams. But to the scientists, each squiggle of light and dark is a potential clue. Was this ridge volcanic? Was that plain resurfaced? Is that circular feature a collapsed dome, or just a trick of resolution? The atmosphere in the lab is not tense. It's not a Hollywood control room where everyone gasps in unison at a data feed. It's calmer, slower. People lean on desks, sip coffee, argue gently about interpretations. Someone quietly eats trail mix over a laptop, carefully avoiding spilling peanuts onto the keyboard. Science, in practice, is more about patient persistence than drama. And that's the real setting. A calm place where the mysteries of a hellish world are teased out not with heroics but with spreadsheets. On one table, a computer hums through climate models, equations running across lines of code, simulating atmospheric layers, winds, and temperatures. The model doesn't spit out a neat answer, it spits out gigabytes of numbers, which then need to be coaxed into graphs and maps. A graduate student stares at the screen, eyebrows furrowed, trying to decide whether the spike in the data means breakthrough or bug in the code. Spoiler, it's usually the latter. Nearby, another machine is testing rock samples by heating them in sealed chambers, attempting to recreate Venus-like conditions. This isn't done lightly. Reaching 860 degrees Fahrenheit in a lab oven, then adding pressure, then sprinkling in corrosive gases. That's not something you do casually before lunch. The ovens are reinforced, the safety goggles are thick, and the scientists stand at a cautious distance, because the last thing anyone needs is Venus simulator explosion as a workplace accident. And then there's the human toolset, endless meetings, whiteboards covered in equations, flowcharts, half-erased sketches of atmospheric circulation. Scientists wave markers, argue about units, and write, "to check later," in the corners, which usually means, "we will forget this completely by next week." None of it is fast. A single Venusian dataset might take months to process, years to interpret, and decades to settle into consensus. But that's the rhythm of the lab, slow, deliberate, and frequently punctuated by coffee. What does a planetary scientist's day really look like? Not spacesuits, not dramatic launches, more like morning, unlock office, boot computer, open email, skim through a dozen new papers, each with titles like, "On the Variability of Sulfur Dioxide in the Venusian Mesosphere," riveting bedtime reading. Midday, lab meeting, PowerPoint slides with grainy graphs, a presenter speaking in sentences that begin, "Well, the uncertainty here is quite large." Lunch eaten at the same time, balancing a sandwich while nodding at cloud rotation data. Afternoon, a few hours running simulations, code breaks, fix code. Code breaks differently. Spend the rest of the day wondering whether this is progress or an elaborate form of self-punishment. Evening, submit draft of paper. Reviewer rejects draft, suggesting another 18 months of revisions. Scientist sighs, brews tea, and accepts that Venus will continue being mysterious a little while longer. And yet, through all this routine, there's a quiet satisfaction. Each tiny dataset, each careful test, each incremental improvement in a climate model, adds a new thread to the tapestry of understanding. Slowly, imperceptibly, the portrait of Venus sharpens. It is not glamorous, it is not fast, but in a way, it is more enduringly human than planting a flag. Because while Venus destroys hardware in minutes, the slow grind of lab work can last decades, patiently outlasting the storms. When astronomers first looked at Venus through telescopes, they thought it might be another Earth. Same size, similar mass, about the same distance from the Sun. Surely, they reasoned, this must be a lush paradise of jungles, oceans, maybe even tropical beaches. In fact, science fiction writers once imagined Venus as a steamy rainforest world, albeit a little too steamy. Then the spacecraft arrived and reality said, absolutely not. The twin comparison quickly shifted from friendly sibling to that one relative who insists on deep frying everything and smoking indoors. Venus is not lush, Venus is lethal, but the resemblance in size and origin makes the contrast all the more haunting. It reminds us that Earth is not the default state of planets. Habitability is fragile, rare, and precarious. Venus shows us what happens when the thermostat is nudged too high, and the air grows heavy with carbon dioxide. Once the greenhouse effect runs away, there's no coming back. Oceans vanish, rocks bake, and the atmosphere becomes a slow cooker of despair. In this way, Venus is less evil twin, and more cautionary cousin. A living demonstration that planets can go very wrong, very fast, and never recover. Earth is cozy today, yes, but only because our climate has balanced itself within a razor-thin window. A few nudges the wrong way, and we might find ourselves on the same slippery slope, though hopefully without the sulfuric acid drizzle. Studying Venus isn't just planetary voyeurism, it's directly useful, because Venus is the poster child of climate catastrophe. If you want to understand how greenhouse gases shape a planet's fate, you can't do better than looking at the place where carbon dioxide became king. On Earth, we worry, quite rightly, about rising CO levels. A few hundred parts per million have already changed our climate. Venus? It laughs in parts per million. Its atmosphere is 96% carbon dioxide. That's not just a warning sign. It's the entire cautionary billboard. By building models that try to replicate Venus's atmosphere, Scientists also learn how Earth's climate might respond to increases in greenhouse gases, or to changes in cloud cover, or to the delicate balance of radiation in and out of the atmosphere. Venus is a giant what not to do case study. Like a neighbor who accidentally set their kitchen on fire by microwaving foil, it teaches you lessons you'd rather not learn firsthand. And there's a strange comfort in that. By grappling with Venus, by building models of its swirling winds and heat-trapping layers, we sharpen our understanding of our own home. The harshest world in the neighborhood becomes an unwilling tutor, reminding us that the line between paradise and furnace is thinner than we'd like to believe. Here's the sobering truth. Venus is quiet. There are no birds, no rivers, no rustling trees, no seasons, no rain in the soothing earthly sense, no whisper of oceans. It is a planet where silence reigns, not peaceful silence, but heavy, oppressive, furnace silence. And yet by studying it, we give that silence a voice. We learn from what's missing. No plate tectonics rumble beneath its crust. Why not? No magnetic field shields it. What went wrong? No water remains. Where did it go? Each absence is a lesson, each silence a story. Looking at Venus in the long view is also a reminder of time. This planet has been hostile for hundreds of millions of years, and it will remain so long after we're gone. Our lifetimes, our civilizations, our worries about tomorrow's weather, all of it is a flicker compared to the unyielding hostility of Venus. But maybe that's the ultimate gift of studying it. Venus tells us, do not take Earth for granted, enjoy your breathable air, appreciate your oceans. Admire clouds that for the most part don't dissolve your skin. This is rare, this is fragile, this is temporary, unless we take care of it. So in the long view, Venus is not just a hell world to point and gawk at. It's a planetary mirror, dark, cracked and distorted, but still reflecting something vital back at us. We've traveled a strange arc together. We began on the surface of Venus, where the air itself would flatten you, the heat would roast you, and the clouds would politely dissolve your face in acid. We lingered over the daily indignities of surviving even a second there, let alone an hour. Then, step by step, we widened the lens. We wandered through the life of Carl Sagan, who took a hostile hidden world and helped reveal its true nature to a curious public. We puzzled at the great mystery of Venus's atmosphere, that strange trick of winds circling faster than the planet beneath them. We sat quietly in a science lab, with its whirring machines and piles of data, watching as patient people tried to coax sense out of chaos. And finally we stepped back, squinting at the bigger picture, at Venus as the lesson, the warning, the reflection of our own planet's precarious balance. It is not simply a world of extremes. It is a mirror, tilted just enough to show us what could happen if we stopped caring about the fragile balance of our home. Looking back now, Venus feels less like a distant ball of rock, and more like a character in its own right, aloof, unforgiving, and yet strangely instructive. The lesson of Venus is not complicated. It doesn't require equations or simulations, though plenty of those exist. It simply says, worlds change, atmospheres shift, climates tip. Venus was once like Earth, or at least more Earth-like than it is now. It may have had oceans, perhaps clouds of water instead of acid. It may have been warm, not blistering, but something tipped the balance, and once it did, there was no return. That story hangs in our skies like a quiet reminder. We are lucky. We breathe air so light we don't even notice it pressing against us. We drink water that falls freely from clouds. We live on a planet where the greenhouse effect is not runaway, but balanced just enough to cradle us. And yet, balance is never permanent. Venus leans in from afar, whispering. Not dramatically, not with thunder or fire, but with quiet endurance, that what we have is rare, and worth preserving. So we leave Venus now, we step back from its glowing horizon, its thick swirling clouds, its cracked and barren surface. We return to our own planet, where the air is soft, the oceans are blue, and the nights are filled with stars instead of acid haze. The story slows, the images fade, the fiery world drifts back into the distance, circling quietly in its eternal orbit. Out there, it will remain hot, silent, and severe, long after we have stopped thinking about it. And yet, its presence will continue to teach, even in silence. Here, in your bed, you are far from crushing pressures and blistering heat. You are wrapped in comfort, in air you can breathe, in coolness that soothes rather than scorches. The contrast is so vast it becomes calming. If Venus is the picture of unlivable extremes, then Earth, this quiet room, this steady breath, this soft bed, is the picture of balance. Let the thought drift with you as you settle. Venus remains distant, unforgiving, locked in its eternal furnace. You remain here, in stillness, in safety, in the rare and gentle miracle of a habitable world. And with that, the story closes. Not with a bang of volcanic eruption, not with a dramatic revelation, but with a long, slow exhale. A reminder of fragility, of comfort, of rest. The fire of Venus fades into the night, and you drift softly into sleep.